Why is sensible heat ratio, SHR, important for mechanical engineers? Imagine trying to keep a room comfortable without knowing how much of the cooling is just lowering the temperature versus removing humidity. That's where the sensible heat ratio comes into play. It's a key number that tells us how much of the cooling capacity is used for sensible cooling, which is temperature control, versus latent cooling, which is about humidity removal. In HVAC systems, understanding this ratio helps engineers design better systems. If the SHR is high, most of the cooling is focused on lowering the air temperature. This means the system needs to handle a lot of sensible cooling, so the cooling coils must be sized accordingly. If the SHR is low, more of the cooling is for dehumidification, which is important in humid climates or spaces needing strict moisture control. Knowing the SHR helps in selecting the right equipment. For example, if you're working with a variable refrigerant flow system, the SHR value indicates how much of the cooling is sensible versus latent. This helps match the system to the building's needs, saving energy and improving comfort. It also guides how you set up the cooling coils. By analyzing the psychrometric process, engineers can see how air properties change as they pass through cooling coils. This helps determine the best inlet and outlet conditions for air, ensuring the system works efficiently. In systems where humidity control is critical, like hospitals or data centers, SHR becomes even more important. It helps ensure the system removes enough moisture without overcooling the space. This balance keeps the indoor environment comfortable and safe. In essence, the sensible heat ratio is a simple but powerful tool. It helps engineers design systems that are energy efficient, cost-effective, and capable of maintaining the right indoor climate. Whether it's cooling a small office or a large industrial space, knowing the SHR makes all the difference in creating a well-functioning HVAC system.